Okay, class. Welcome to another Friday edition of I'm Here at School, still making you a video to watch over the weekend. Yeah, I know, it's my fault. Blame it on me. Anyway, we are going to go over about 4 slides today that I have. We're going to start out just talking about polynomials. So this is the introductory video to polynomials, and what we're covering in the first lesson is just classifying them. So what are we going to say when we talk about them so we get on the same page there? We're going to use a table of values to learn a little bit about it. We're going to talk about something called turning points and end behavior. Okay, so here in my first little board, you can see that I've got a classification for polynomials. So this is just what we're going to say to each other when we're talking about it. We need to use these terms so we're on the same page. So a monomial is just a polynomial with one term. And I'm going to get crossed up a lot because I'm tired. Other one, binomial, that's a polynomial with 2 terms. And then trinomial is a polynomial with 3 terms. You can keep going on and on and on. After 3, we're just going to start saying that it's a polynomial with n terms. So if I got 5 terms, I'm going to say it's a polynomial of 5 terms. Okay? That's just going to save us a little time in that respect. And when we talk about the degree, that's just the highest number exponent that we have in the entire polynomial. So here's an example of a polynomial just written out, 3x cubed, which you haven't seen yet. This is new, so you're going to see higher than just 2. That's what we were doing with quadratics. So anyway, back to this. 3x cubed plus 5x plus 7. That's a polynomial. Now, it's a specific polynomial. It's actually a trinomial because it has 3 terms. Just count them here. 1, 2, and 3. So it's just how many terms you're having added together. So our degree here is the other thing we need to look at. I have something that doesn't have an x with it. I have an x here, and then I have an x cubed. So we're going off of our highest exponent value. So in this case, that's 3 cubed. So our degree of this polynomial is just degree 3. Okay? So let's move on to using tables. And this is going to be a big board, and I'm sorry about that. It's got a lot of mumbo jumbo on it, but it's easy. I promise it's easy. So we're just using a table of values to determine the degree of a polynomial. So we can actually take just a table of x and y values like I have here, and just based off of this and this alone determine what the highest exponent value or degree of the function is. And that's going to come in a lot of handy because once you figure it out and once we've learned a little bit about polynomials, we're going to learn a lot about how each specific one acts. So if we can figure out what the degree is, we know a little bit more out of it. So all we're doing here, we're giving you the table of values. You take differences of the y values to determine the degree of the function. So one of the biggest notes I have here is that your x values need to be listed in order. They also need to be evenly spaced. So if you see here my x values, I have -3, -2, -1, 0, 1, 2, 3. So it's steps of 1 in between each of those. And then I'm just listing them in order. So make sure you don't get these out of order. Get your x's lined up, match your y's with it, and then go ahead and work out the problem. So here we're just taking the differences of y values. So we're only using the x's to really get everything organized. So we've got all of our y values here. I just wrote these in a nice little line next to my table. So what you're doing with the differences of values is just taking this number and subtracting this number. So in that case, that's 7 minus -1, which makes it 7 plus 1, because minus and negative makes it plus the positive version. So -7 plus 1 is -6. And I do this and I repeat all the way down the table. So my next step is -3 minus -7 So that's negative 3 plus 7, which is 4. So on and so forth. As I keep going, we can look at the very last one. 7 minus 9 gives me negative 16. Now, but I just didn't write out my little negative symbol next to the negative 7. I was worried I was going to have to restart the whole video. Anyway, so I've got the negative 7 minus 9, so that's negative 7 minus 9 gives us negative 16. So like I said, you're taking this number and subtracting the number above it all the way down. So this number subtract this subtract this subtract this, and then you get all of these values. So what you're looking for is all the same value. Once you get to that point, you know you've determined the degree. So we do it here at the next step, and our answers come out to be different numbers all the way around. So we need to do another step. When we get to this step, we start noticing that all of my answers come out to be negative 6. That means that all of the values are constant values. So, because all values are constant after the third difference, so this is after we've done the third difference, the function degree needs to be of degree 3. So the same number of differences that you have to do to get the same number from top to bottom is going to be the degree of your function. Okay? I know that's a lot to take in right here, but you're just taking, again, your y values, subtracting this one from the one above it, so this from the one above it, all the way down. Get your answers, and if they're not the same number, keep doing it until you get that. Once you do, you found the degree of the function, so after the third set of differences that we did, that was the third degree because all of these came out to be the same. Okay? Now, the last two things that we're going to look at deal more with what the graph looks like and less about how the graph behaves. I'm going to say that really carefully because the graph or the function will still behave this way and you'll be able to tell it from the function, but we're just going to learn about looking at the graph first. So this is an introduction to turning points. Now a turning point in the graph is just where the graph changes from increasing to decreasing values. So I'm just going to go into an example. It's a lot easier to see than explain out. So given a polynomial x cubed minus 3x squared minus 4x plus 12, show the turning points. And I'm going to give you a calculator to use on this part because that's going to be important that you see it visually. And I'm not showing you how to graph these right off. We're going to do a little bit of a discovery lesson on Monday. So when we do that, I'll show you a little bit more about how to graph it. But for right now, we're going to use our graphing calculators to get the graph of our polynomial. So as you see here, it comes out to this really, up and down and back up type thing. What I'm looking at here now is for turning points. So if you notice here, I'm increasing along my graph all the way up to this point right here. At this point, you'll notice that I start to decrease in values. I decrease in values all the way to this point here. Now at this point, I start increasing again. It keeps going on forever like that. So I go from increasing to decreasing and then back to increasing again on my y values. So we're looking at the increasing and decreasing of our y values. So you have two turning points, just this big black dot right here and this big black dot right there. So those are our two turning points. And during our discovery lesson, I'm going to ask you to take notice of how many turning points you have in relationship to the degree of your function. So this is degree 3, and you have two turning points. So I'm going to let you go come up with your own ideas past that because it's not always the case that if I have degree 3, I'm going to have two turning points. And you're going to see examples of that coming Monday. Okay? So the last thing that we need to talk about is going to be end behavior. This is really, really easy to see. So I heard Mr. Melton across the way talking about end behavior and how in most graphs, end behavior, it's just what's happening in the center of the graph. Right in the center of it is where all the action goes on. And then when you go really far out left and really far out right in the function just keeps doing the same thing, increasing or decreasing. And that's called end behavior. So it's just what happens to the far left and the far right of a function. So when I'm talking about left and right, it's all my really positive x values and all my really negative x values. So that's what I'm looking into. So I've just got a bunch of different graphs here that we can talk about end behavior. This is not all the end behavior you're going to see, but it's most of it. So for the x squared function, we've just dealt with x squared and negative x squared quite a bit. And hopefully you've seen linear functions, just a line. And we could talk about end behavior. So as my x's get really, really negative, this function is just going to keep going up and up and up and up and up. Okay? We're going to say that that goes to positive infinity. Okay? So that's what the left side of my function is doing to the far left. And then to the right, it's also going to positive infinity. So when we talk about end behavior, we talk about up or down. That's basically the terms we use. So in this case, this keeps going up forever. This keeps going up forever. So this is an example of up and up. Okay, that's just up and up end behavior. Now on this one, we have a linear function. So as our x's get really, really negative, this is going to keep dipping down, being really, really negative. So as our x's increase, so does our line, and it keeps going up. So this is a case where this goes to negative infinity. This goes to positive infinity. So our end behavior here is down and up. Okay? So in this case, we've got the x squared function just flipped. That's basically all that little negative in front of the x squared does. It flips it across the x-axis. So instead of going to positive infinity and positive infinity, it goes to negative infinity and negative infinity. These are really bad infinity signs, so sorry for that. So our end behavior here is just down and down. In one more case, this is a graph that I kind of went over a little bit of an easier, a harder version earlier. So this is the easier version, and that's just y equals x cubed. So in this graph, we've got, as you go out negative, really negative values, this just keeps going down and down and down. As you get more positive in your values of x, it goes up and up and up. So I get that this part goes to negative infinity. This goes to positive infinity. So again, I have the behavior of down and up. Okay? So it's just looking at my graph and saying my left side goes up, my right side keeps going up and up forever. And there you go. It just gives me up and up, down and down, down and up, and I did down and up here. There's one more case, I believe, where you can actually have a graph that goes up and down, which I didn't cover. Don't know why I didn't pick to just make this like negative. So say the line was going down like this. I would have as my x's go really, really negative, this line would keep going up to positive infinity, whereas this line here would go down to negative infinity. So I don't want to stay here and talk all night because I could, but be prepared for Monday. Monday I will be videotaping the first block class. So make sure you guys have watched these videos, taken really, really good notes over it. And even for the classes that aren't being videotaped, still I need you guys to watch the video really good, take good notes. and I'll end up seeing you Monday. So you guys have a great weekend, and if you're viewing this Sunday night just to cram it in, good job. And I will see you tomorrow. Thanks, guys.